All right, let's do some math. Merry Christmas. So what I'm going to do is start with some order of operations stuff, because order of operations is really, it's a crucial part of being able to solve all math problems. And so that's why they're there, to remind us of these steps that we're supposed to take. So following the typical PEMDAS, parentheses, exponents, multiply, divide, add and subtract, where multiplying and dividing and adding and subtracting carry equal weight. So if they're both there, you just go left to right. Another version of this is called GEMS. I wanted to switch colors. Apparently that's not in the cards. Oh, maybe it is. Oh. The other version, GEMS, you got grouping symbols, exponents, multiplying, which goes with dividing, and subtracting, which goes with adding. So instead of seeing both of these letters, you only see one of them, which is helpful in understanding that multiply doesn't come before divide unless it comes first in the equation, that they're the same, they have the same priority. Okay, so number 11 is where I want to start. If you've got parentheses, that is a classic grouping symbol. But if you look in these parentheses, you have another grouping symbol. You have the division, the fraction bar right here, which is another symbol that groups two things together. So it's grouping the bottom operations and the top operations. So before you carry out that dividing, you should simplify the top and the bottom. So in the parentheses, now I will have negative 12 over 2 plus 2. I'm lagging so bad, it hurts me. Okay, and then if I simplify 12 over 2, it becomes 6. So I'll have negative 6 plus 2, which is negative 4. I'm going to leave this minus sign that's in front of these. And now inside those parentheses, there's nothing else I can do. Inside that grouping symbol, there's nothing else I can do. So I would then move on to exponents. I don't have any, but I do have some multiplying. So let's do the multiplying now. So we've got 3 times negative 5 times negative 3. We can just go left to right, but it really doesn't matter the order. You should get the same thing. 3 times negative 5, negative 15 times negative 3 is a positive 45. 45 up here also. All right, and then the only other option that we have still is subtraction. And this kind of shows you why there's no priority of subtraction over addition, because if I subtract a negative number, that's the same as just adding a positive number. So addition and subtraction are just two sides of the same coin. If you see these parentheses here, it's just saying that this negative should be applied to everything in the parentheses. There's only one thing, but you might think of it as distributing a negative 1 into there. And so it's going to become 45 plus 4, which is just 49. Now I'm going to try to jump to 13 and do that one pretty quickly so we can move on to some more exciting things. So 1 plus, here is that new grouping symbol that we've talked about again, the division or the fraction bar. So the top we need to treat as if it's in parentheses, and the bottom we need to also treat as if it's in parentheses as well. So negative 11 plus 2 is negative 9. That's being divided by negative 3 minus negative 6 is the same as negative 3 plus 6, which is just 3 plus 5 times negative 2. So I want to do this division right here and do this multiplication right here before I carry out adding and subtracting. So I've got 1 plus, and then -9/3 is -3. And then I have a +5 times a -2. So that makes -10. Now I only have addition and subtraction left, so I'm going to go all the way to the left. 1 plus -3, that's the same as 1 minus 3, is -2 minus 10, -12. So that is order of operations, dealing with only numbers. Now let's simplify an expression. Let's do number 17 here. So looking at number 17, you've got some parentheses. You have some exponents, you have multiplying, you have addition and subtraction. However, if you think about what we can actually do, it's not as much. So parentheses are grouping stuff together, telling us to do these things first. But can I add a -4k to an 8? No, I can't, because they're not like terms. They don't have the same variables to the same powers. I can't subtract a 4k squared from an 8 because they're not like terms. Same thing over here. So really my parentheses are done. And then you look at the exponents. You look at the exponents and you see k squared. Well, I can't square k because I don't know what it is. So basically have finished those as well. That brings us into multiply and divide. Now, while I can't multiply -4 and k, there is a little multiplying I can do, and it has to do with what's on the outside of these parentheses. So the parenthesis in the front here, the first set of parentheses, is saying that we should do whatever's out front of those parentheses first, or we should do all of this first. But really, there's not anything we can do except like distribute a 1 in, which changes nothing. So I'm going to take those parentheses away because they don't have a function right now. But the next parentheses do have a function. They are telling us not to just subtract 8k, subtract k squared, and add 8. They're telling us to subtract all of this, everything in there. So we're subtracting a -8k, or distributing a -1. So really, we're adding 8k. We're not subtracting k squared, we're subtracting a -k squared, which is the same as adding k squared. And so you'll see that what's happening here is all these, all those operations, addition, subtraction, are being flipped. The signs are being changed. So now let's go through and let's combine some like terms. We got -4k plus k squared. So I'm starting with the exponents that is the largest, and that gets me -3k squared. And then I'm looking at -4k and 8k. That gets me plus 4k. And then I've got 8 minus 8. So those are just going to cancel each other out and leave me with just this as my final answer. Okay, let's do number 18. This is something that I have seen or noticed that we struggle with a lot, but it's really foundational. So two binomials, which means just two terms, a binomial that are being multiplied to each other. So not only is 2x, we're doing 2x minus 7, but we're multiplying that whole thing by -3x plus 4. So we have to do 2x times -3x, which is -6x squared. But not only that, we have to do 2x times 4, which gets us positive 8x. So that takes care of the first term there, the 2x. Now I have to multiply -7 by -3. That gets us a positive 21x. And -7 times 4, which gives us -28. Minus 28. Then the last step, you want to combine some like terms. So we're not solving for x here. There's no equal sign. We're not trying to say x is a certain number. We're just taking an expression and simplifying it. So 8x plus 21x makes 29x. And then the negative 28 just comes down here. All right, next up, let's do number 20. Oop. I'm still lagging so bad. It hurts me. Try to close down pretty much everything going on, but still slow. Okay, so number 20, again, thinking of order of operations, there's no equal sign yet. That comes in number 22, but we are trying to simplify what we can here. So combining like terms, doing the operations that we can. We can't do anything with the exponents because we don't know what y is, but we can multiply this 3y cubed into this set of parentheses here. So that's what we're going to do. The 8y to the 5th, we'll mess with that later, minus 9y. Then we come to, we're adding a 3y cubed, but not by itself. We're adding it after it has been multiplied by both of the things in the parentheses. So 3 times 2 makes a positive 6. So we just look at the numbers first. And then y cubed times y gets us y to the 4th. Then we do a positive 3 times a negative 6. That gets us negative 18. Y cubed times y squared is y to the 5th minus 7y squared. So now already it's a much simpler expression to simplify. We are just going to combine like terms and put it in standard form, which just means the highest or the largest exponent should come first and then go in decreasing order from there. So 8y to the 5th minus 18y to the 5th. That gets us negative 10y to the 5th. So y to the 5ths, you have to deal with those at the same time. Y to the 4th is not a like term, so it doesn't go with those. It doesn't have any like terms. So we'll just write it next, a positive y, 6y to the 4th. We don't have any y cubes, but we do have a y squared, but we only have 1. So we just write it next. And then the last term, negative 9y. And that is the final answer. So let's move on to the solving world. So all that has been simplifying. So let's solve a couple equations. This means we want to know what the value of the variable should be to make this a true statement. That's what it means for something to be a solution. It's like, I don't know, it's like if I want $5, then you could say, I have 4 plus some amount is equal to 5. Well, what do I need to add to $4 to get to 5? $1. And there's only one solution to that. We have some equations here. Let's solve them. You look on your first step is to simplify both sides. So that's exactly what we were doing in 21. We were simplifying. So we're going to simplify first and then go about the solving. So if you look on the left side, there's nothing we can do. We can't subtract 3v from negative 7 because we don't know what v is. They're not like terms. On the right side, we can't add 5v and 4. So we're going to multiply this or distribute this 4 into the parentheses. 4 times 5 makes 20v, and 4 times 4 makes 16. All right, your next step is that you want to get all your variables to the same side. So once you've simplified everything you can, move all the variables to one side. I'll move the v's to the left because that's what people traditionally do. If you like to avoid negative numbers, you might move the 3v over to the right. But if I have 20 v's on the right side and I don't want them there, I have to take them away. That's why we put subtraction. So we had something, we wanted to remove it. Well, on the left side, if we remove 20 from the right side, we have to remove 20v from the left side. So on the right side, I've got no more v's. All I have left is that 16 over there. And then on the left side, I have -7 minus 23v. Now I need to get the -7 away. So if I owe 7 of something, then I need to add 7 to cancel out that debt. Then I'm going to add 7 to the right side too. The golden rule of algebra says if you do it to one side, you got to do it to the other to maintain this thing called equality. So -23v is equal to 23. You divide by -23 on both sides. Eventually, when it loads, you'll have v equals -1. All right, real quickly, let's do number 23 and talk about what it means. Not a very difficult problem to simplify, but maybe understanding the results is kind of difficult. So -6n plus 6n equals 3. We already have all our variables on one side of the equal sign, so we want to simplify and solve. -6n plus 6n is 0n, and it's equal to 3. And so you might say, well, what can I multiply by 0 and get 3? And hopefully the answer to you is nothing. There's no answer to that. There's no number I can multiply for n and get 0. If I have 0 n's on this left side, what do I have? I have nothing over there. So it's trying to say is nothing is equal to 3. We know that to be a false statement. That's not true, which means that this equation here has no solutions. There's nothing I can plug in for n and turn this into a true statement. If I try to plug in a 2, then I'd have -12 plus 12 equals 3. And that's just not true. So there's no solution here. If you end up canceling out all of your variables and you have a false statement, then there's no way that that could be solved. There's no value of n that could make this true, so there's no solution. But if you cancel out all the variables and you have something like 3 equals 3, that's true. And there's nothing that you could put in for the variable n to make it false. So if you have a false statement at the end with no variables, there's no solution. If you have a true statement, there's an infinite number of solutions. Okay, let's jump to this one, 28, and let's talk about fractions. Fractions are just things that are being divided, but the division's been written in a different way to make it kind of like all the same term, 5/2. And we think of it as one number instead of two numbers, but really it's just a 5 that's being divided into 2 pieces. So we're going to do the same thing here. We want to know what x is. And so we're going to distribute this 5/2 into this set of parentheses here. So we need to multiply some fractions here. How do you multiply fractions? You just multiply straight across the top, straight across the bottom. So we've got a positive 5/2 times a -11/3. 5 times -11 makes -55. Over 2 times 3 makes 6. Okay. Honestly, I guess what I should suggest is doing 5 times 11 is 55. 2 times 3 is 6. And then because the 5/2 is positive and the 11/3 is negative, positive times a negative makes a negative. And we have an x there. Then we have a positive 5/2 times 1. So that just means plus 5/2. And it's equal to 415/12. All right. So we want to solve this the same way, just like it was, if it was -2x plus 4 equals 10, then we would subtract the 4 from both sides. We're gonna do the same thing here. We're gonna subtract the 5/2. We don't treat it any differently as a number just because it's a fraction. That just means it's not a whole number, it's not an integer. We get -55/6x. So these cancel out here. And then we do 415/12 minus 5/2. If you want to subtract fractions, they have to have the same denominator. So if you try to make the denominator over here into a 12, you got 30/12. But you can also just subtract those things on a calculator. And you get 385/12. All right. And here is where I may differ from some people in that I don't treat this -55/6 like it's one number being multiplied by x. I treat it like an x that's being multiplied by 55 or -55 and divided by 6. Two separate operations. And for me, that just makes more sense. So try to change colors here for these operations. So what I'm going to do is this x is being divided by a 6. So I'm going to do the opposite and I'm going to multiply by 6. The opposite of dividing, multiply. That will cancel that 6 out. It divides out. 6/6 is 1. Okay, now I need to also multiply by 6 on the right. I get -55x equals 385/2. And my last step is to divide by -55, not add 55, because there's multiplication going on between the 55 and the x. All right, and then what happens when I do this? Divide by -55 over here. Seems kind of crazy, but let's think about it if we had written it like this. 385/2 divided by -55. You could put that in your calculator and it would tell you how to do that. But we can treat this like, how do we divide fractions? You're like, well, -55 isn't a fraction. It is if we want it to be. You can just put anything over 1. If it's just an integer, just a whole number, just put it over 1. And now it's a fraction. How do we multiply fractions? Well, we don't. We multiply by the reciprocal, -1/55. And there are lots of ways to go about simplifying this. We could divide the whole thing by 5. I'll just pull out the calculator. We can do 385 times -1. That gets us -385. I decided to do something different. Normally, I wouldn't type in 385 times -1 in my calculator. 2 times 55, that makes 110. And then we can simplify that. Hopefully you see they can both divide by 5. So I'll take that number and I'll divide it by 110. Not negative, struggle bus. And I get -3.5. Okay, so you can write that as an answer, but if you want a fraction, you hit math, enter, -7/2. That tells me there was a bigger common factor than just 5. 55. Yeah. And that's number 28. Okay, fractions make things a little harder, but still very doable. Okay, while we're here, let's go ahead and knock out 33. More fractions, some parentheses, trying to solve for x. We want to know what that variable needs to be to create a true statement. So what I would first do is we need to simplify both sides, which involves doing the operations that we can, trying to consolidate some like terms, so that this is just a simpler equation to solve. Okay, so there are other things we could do first, but I think this is the easiest way. So we want to do distribute that 2 into those parentheses. That will get us 2 times x, which is 2x, 2 times -5, -10. Then we want to distribute this 1/3 into the parentheses here. So 1/3 of 9 is just 3, or you could think about that as 9 divided by 3. Remember thinking of fractions as multiplying 9 times 1 and then dividing by 3 if you would like. So we've got plus 3x that goes here. And then 1/3 times -18 is -6. On the right side of the equals, you've got the 8, and then we want to distribute the 7, the plus 7x, and then 7 times -4 is -28. All right, so now that we've got everything distributed, all we have left is addition and subtraction. So we want to do those things on either side of the equal sign to consolidate some like terms. So 3x plus 2x makes 5x, and then -10 minus 6. Wow. -10 minus 6 gets us -16 equals, all right, then I'm going to write 7x. It doesn't have any like terms with it, but then 8 minus 28 is -20. If I were doing this one by myself, I would probably subtract 5x from both sides. So I'm going to get all my variables on the right side because that way they stay positive and the numbers will stay positive as well. It's just a little easier to me. So we get -16 equals 7x minus 5x is 2x minus 20. So after you simplify, you want to get all the variables to the same side, and then you want to start solving for x. So you do inverse operations and add 20 to both sides. Get -16 plus 20 is 4 equals 2x. These cancel out. Divide both sides by 2 and you get x equals 2. So the thing we should be able to plug in there and come out with a true statement is a 2 for that x.